Hi, Science 10. So I wanted to go over the answers to that first part of velocity um, that we looked at. And so what we'll do is I'll go over the answers to these, and then I'll give you some work just to continue on um, looking at calculation of velocity using both equations and graphs. So remember, we started by looking at the definitions of in terms of the variable for velocity, displacement, and time, and then we had this formula here to get velocity, and then we had two other versions where you could either solve for displacement or time. Okay, so with this first part here, you have to look at what you're solving for and then use the appropriate equation. So that's basically what we do in physics. We identify what we're given in the question and what our unknown is. So that means what we're solving for. And when we pick the appropriate equation, it's always in terms of our unknown. So if our unknown is t, then we would be using this one. Okay. So check over your answers for the table part there. What I want to focus on is the word questions for number 3. A few of them here. So let's start with number 3E. Okay, so E, F, and G were kind of the harder questions. So just before we get there, so again, just like you would in math, make sure you're showing your steps. So in terms of showing my steps, what I want to do is basically show what numbers I'm using and how I'm using them in terms of the equation. And then when I get my final answer, I want to make sure that I have the appropriate units. Look at C. Notice how they told us that you're going east. Because of that, I can put my answer in displacement and add in the east part. So you always, when you're solving for a vector, give as much information that you're provided by in the question. Okay, so if you're not provided that information, then we can just use plus or minus. Okay, so let's start with 3E. So E, F, and G, where you would have had problems with these questions is if you basically just took the numbers as they were and just did the calculation without first converting. So what we talked about is if you're either working in kilometers per hour, and hours, or you're working in meters per second, and seconds. So there's kind of two there's two ways to go about it, and so the units have to be in one of those two buckets. Okay, so here I've got 3 kilometers. So if I want to keep this as kilometers, then I need to change this to hours. Okay, so if you kept it at 8 minutes, you would have got the wrong answer. So what I do is, if I got 8 minutes, I divide that by 60, because there's 60 minutes in an hour, and that gives me 0.13 hours. Now I can do the calculation for velocity, 3 kilometers divided by 0.13 hours, and that's going to give me 22.5 kilometers per hour. So again, notice how I have units for my final answer. Okay, so this one here, we've got to change the 8 minutes. There's another way to do this question as well, but it's a little bit more work. You change 8 minutes to seconds, and then you change 3 kilometers to meters, and then you'll get an answer in meters per second instead of kilometers per hour, which is fine. Okay, but again, just recognize that you need to change one of the units, or if not both, if you're going to go the other way. Okay, for F, so here I got 2,400 meters, and then I got 3 centimeters per year. Okay, so I put the wrong unit here. Okay, so this should be years. Okay, so that's 3 centimeters. Okay, so I want to change that to I divide this by 100 to get that into meters. Okay, so I got 0.03 meters, and this is meters per year. Okay, so meters per year. So how I know the question, my answer should be in years, is because the question specifies. Okay, so it says in years. Okay, so again, I divide that by 100 to get in meters, and that's meters per year. And so I got 2,400 meters divided by 0.03 meters per year, and that gives me 80,000 years. Okay. For G, I've got kilometers per hour, and I've got seconds. So I want to change this to hours. So I divide by 60 to get it into minutes, and then I divide by 60 again to get it into hours. So again, there's 60 seconds in a minute and 60 minutes in an hour. So I got 0.000103 hours. And so now I can do the calculation, and I get 0.65 kilometers. Okay. So watch, like I said, these three here were the more difficult ones. Okay, so you got to watch your units. Okay, let's look at the next part that has to do with the graphing. So again, the slope, we talked about how to do the slope calculation as rise over run. The slope of a position time graph, what that represents is velocity. Okay, so it's another way. What does a straight line on a position time graph represent? That represents uniform motion. Okay, so again, uniform motion indicates that your speed is staying the same. So you're not going faster, you're not going slower, and you're not changing direction. Okay, so you're keeping the same speed and same direction. Okay, so definition of slope has to do with the progression of the line. So it's a description of how steep or shallow the line is. The other word for the slope is they refer to this as rate of change. So it describes the rate of change between two variables. Okay, and again, variable is the letters of an equation that represents something, like D represents displacement. The formula to calculate the slope of a straight line is rise over run. Okay, so rise has to do with the change in height, and then run has to do with going across. Okay, so let's look at this calculations here. So for B, I mean, I did the calculation, like I looked at the rise. Because it's staying the same, it's a rise of 0 meters, and then going from here to here was 20 seconds. So 0 divided by 20 is 0 meters per second. I didn't really need to do the calculation. Anytime you see a flat line like this, like a perfectly flat line, it's always going to have a 0 slope. Okay, so it's always a 0 slope for flat lines. Okay. Now, the line C, okay, so line C is the one where you're going from here to here. So this one, when you're going up and to the right, this is what we call a positive slope. Okay, so when you just look at the picture, you should recognize that you should be getting a positive slope here. Just like when you see this one, you should recognize that you're getting a 0 slope. So we're starting here, and this is our 0 mark. Okay, 0, 2, 4, 6, 8. So we're going up from here to here. Our rise is 8 meters, right, from 0 to 8. And we're going from 5 seconds to 10 seconds. So our run, so going across, is going to be 5 seconds. So it's 8 meters divided by 5 seconds, and we get 1.6 meters per second as our slope. Now, if you compare line A, which was this one, and line C, which is this one, what you notice is line C is much steeper than line A, right? And that's shown here by the slope, 1.6 versus 0.27. So the slope sort of represents the steepness of the line, right? Think of it as a hill, right? The steeper the hill, the bigger the slope is going to be. Now the last one here, line D, that's the one where we're going from here to here. And so whenever the line goes down and to the right, so as opposed to this one which was going up and to the right, this is what we call a negative slope. Okay, so a negative slope means just that. You're going to get a negative value. Okay, whereas this is a positive slope. Now again, I keep emphasizing this, but in physics, the negative for a lot of things that we look at doesn't indicate that you're losing something. The negative has to do with the direction that you're going. Okay, so it's more to do with direction, and it's not like like a basic math where you're subtracting something. So we start here at 6 and we end up at 0. Okay, so remember when we talk about your displacement, it's from where you end up. So we end up at 0 minus where you begin. So it's 0 minus 6, which equals -6 meters. Okay, so that's where we got the -6 meters. Okay, so again, it's always final minus initial. Okay, and then your run, you're going from here to here. That's 15 seconds. Okay, so -6 divided by 15, and that gives you a -0.4 meters per second. So again, this is a negative slope. So it doesn't mean that you're slowing down or losing something. It just means that we're going in the opposite direction that we'd be going in the other two here. Okay. All right. So I've got another couple of worksheets just for you to get some more practice on this. And so I'll do the same thing. I'll go over the answers with you for the next class. So I'll post the next class on Thursday, and I'll go over those answers with you. So as you might have heard, we're going to be coming back next week. So that would be June 1st. So just to give you some information, what we'll basically be doing is for the remainder of the school year, the instruction and the materials will still be given online. So exactly as we've been doing. And what those class, like real class times, are there for is if you're having any difficulty with any of the work that we've done or what we're working on right now, and you just need some extra help with that. Okay, so I won't be providing new instruction or materials during that time. Okay, so if you're understanding what we're doing and everything's working out all right, then there's not really much for you to do there. But if you're struggling and you need some extra help, then definitely you should be trying to make it out if you're comfortable. Again, if you're comfortable, because the priority is for you to feel safe. I'll be there, but if you're comfortable coming in and you need that extra help, then by all means come on by. But if you're managing well, then there isn't really a need. Okay. So I just thought I'll let you know about that. So finish the attached worksheets on sort of the same stuff that we're looking at, and I'll go over these answers with you on Thursday. Okay, which will be the next posted lesson. Okay, so again, stay safe, and I'll talk to you again on Thursday. Okay, bye now.